Hello everyone, I am Medha Malik and we'll be discussing the topic recurrence relation in this presentation, in this video. Now, the topics that I'm going to cover in this are introduction about recurrence relation, then methods of solving them. There are certain methods of solving a recurrence relation so that we can find out the time complexity of a particular algorithm. So we can solve it by iterative method, recursive tree method, or master method. So in this video, we'll cover the first method for solving the recurrence relation, that is iterative method, right? So let us begin. So in a recursive call, in a recursive function, there is first of all a base condition, and second is the part where the function calls itself, यानी कि हमारा recursive call, recursive condition. So when an algorithm contains a recursive call to itself, its running time can be described by this equation, a recurrence equation, and this equation that defines a sequence based on a rule that gives the next terms of a function based on the previous terms of the function. So this functional relation between the independent variable in a function, suppose x, and the dependent variable of f of x in each function call and the various orders of the function. This relation between all three can be said as the recurrence relation. The recurrence equation can be formed from this. So let us take an example how we can form a relation from a recurrence relation from a algorithm. So I'm taking a function void f1. I'm taking integer variable n as the argument in this. Now, first of all, the stopping condition, I'm taking n equal to, if n equal to 1, then I'm returning a certain value, suppose 0. Now, in the recursive part, I'm returning the function call with the new value of n, yani ki updated value of n with n minus 1. So it consists of, first of all, a stopping condition and the recursive condition. So how we can find out what will be the time complexity of this? First of all, we have to know how much time it will take for execution. So this statement, first statement will take unit time for execution. Then second statement also will take unit time for execution. Now this third statement, which is the recursive call, how much time it will take? It depends on the value of this variable which is decreasing in each function call. So it depends on the function call which is for n minus 1. After that, it will keep on decreasing until it reaches the value 1. Then it will return 0. So how we can write it in the recurrence relation form? Suppose t of n function, this will return value 0, यानी कि आपका how much time it will take? 1 unit time when n is equal to 0. And if n is greater than 0, then it will take t of n minus 1. Right? So this will be the recurrence relation for this particular algorithm. Let us understand again with one more example how we can form a recurrence relation from an algorithm. I'm taking Fibonacci series recursive call, suppose fib function with integer n. The first condition is for the first value that I have to print for Fibonacci series. So if n equal to 1, that is the first term for this series. So I'll return the value 0. Then else if n equal to 2, the second term in the series, I'll return 1. And for any other value which is greater than 3, which is greater than 2, यानी कि हमारी फिबोनाची सीरीज में थर्ड टर्म ऑनवर्ड्स हम क्या करते हैं, we calculate the sum of the previous two terms. So here fib of n minus 1 plus fib of n minus 2 we are taking, right? Now calculating for this, unit time will be taken for first condition. The second also unit time will be taken for execution. And for this recursion call, that depends on the value n minus 1 and n minus 2 function call. So it will take time tn minus 1 plus t of n minus 2. Now writing the recurrence relation, t of n will be unit time when n is equal to 0, then again when n is equal to 1, and t of n minus 1 plus t of n minus 2 for any value of n which is greater than 2. Sorry, this is for n for 1 and n of 2. So any value greater than 2, it will take previous two terms for summation. So from this recurrence relation, we can find out the time complexity of any algorithm. For solving the recurrence relation, we have certain methods. Let us discuss them in detail. There are 3 methods to find out the time complexity. First is iterative, method. So what we do in this method, we keep on substituting the value in the equation, the recurrence equation, until we reach the stopping point, that is the function is removed from the equation. Until the function is removed from the equation, we keep on substituting the value of the updated variable value in each function call, right? So it takes substituting given function repeatedly until it is removed from equation. Right? Let us take an example to understand it better. Now, I have a function called with the recurrence relation t of n. It is of order of 1 when n is equal to 1, and it is of order t of n minus 1 plus n when n is greater than 1, right? So what we can do, we can form this equation from this. T of n is equal to t of n minus 1 plus n. This is the first equation that we get from this recurrence relation. Now, in each recursive call, if there is n minus 1 in each recursive call, what will be happening? The value of this n variable will be keep on decreasing by 1. So we'll just substitute this value of n in each equation now, forming for n minus 2. For n minus 2, if I write here, sorry, this is for t of n. So replacing by n minus 1, this will be n minus 1 minus 1 plus n minus 1 plus n. We are just replacing n minus 1 into first equation. N minus 1. So when we do that, what happens? It becomes t of n minus 2 plus n minus 1 and plus n, right? Now again substituting it here, replacing n with n minus 2 so what will be the next equation? T of n minus 2 minus 1 plus n minus 2 plus, from the previous equation, these last two values, n minus 1 plus n will be here, right? So it will become t of n minus 3 plus n minus 2. So here we are forming a pattern, right? N minus 1 plus n. So if we keep on replacing the value of n, suppose, so the value of n will keep on decreasing. So I'm taking here, suppose k times, I'm replacing the value of n. So for the last value of k, it will reach this t of n minus k. I'm taking it as t of 1. I'm supposing that the for k times when I'm repeating this replacing of the value of n. So t of 1 will reach, and when the value of n is equal to 1, it will return 1, right? So I can say n minus k equal to 1, or I can also write it like this, k equal to n minus 1. Now replacing the value in the final equation, t of n minus k था ना, k की जगह हमने क्या करा, n minus 1, right? Now again plus n minus k minus 1. So that will be n minus 1 minus 1. k की जगह आ गया n minus 1 और minus 1 हमारा for the next value of k, right? Then again plus n minus k minus 3. So n minus 1, ये k की जगह है, minus 2, right? So this will keep on going till n, right? Now what we can conclude from this equation, this first term will be equal to t of 1, है ना, plus n minus n minus 1 minus 1. This will be 2. Then again next term n minus 1 minus 2. This will be 3, then 4, then till n. So T of 1 is 1. So this will become the summation of n natural numbers, and the summation of n natural numbers can be written by the formula 1 plus 2 plus 3 till n can be written by the formula n into n plus 1 by 2, right? So we can replace it here also. T of n will be equal to n into n plus 1 by 2. So we'll take the highest order that can be formed from this equation. So T of n will be of order how much? Order of n square. So this is how we solve the iterative method. In the next video, we'll solve another example of iterative method. Thank you.